Well, hey everyone, it's nice to see you all. I'm back again. I actually don't think I put an intro slide on this slide deck at the end because apparently I don't think I need an introduction. I'm actually really happy that I'm the last presentation, which sounds kind of weird because it's like, well, surely you'd want to be the first one, right? Because that's the one everyone's going to be. People are asleep by now. And yes, you all might be asleep, but I'm hoping I can wake you up. Because what I really want you to do after listening to this talk is never ever watch another one of these conferences again. Well, actually, no. Do go watch another one of these conferences, but don't ever watch my videos again. Watch as the API security expert you are, right? Don't watch with the intention of learning, watch with the intention of learning something new. And what I find when I speak to a lot of folks is they decide, I'm going to do API security, I'm going to do API hacking. And they kind of build it up in their head to be something much greater than it is. So when they actually go to say, look at an API CTF, look at API bug bounty program, look at a client or maybe an API that's in your organization, and they think, I'm going to go hack that, they feel really, really overwhelmed. They don't know where to start. And so this is what I'm going to give you today. I'm going to give you a place to start. I really want you to listen to this talk and feel inspired and feel ready to take those first steps yourself. Because I will be honest, there is no critical mass of knowledge that you need to do API hacking or API security. There is no, here is everything you need to learn. It is always just experimentation. It is always a continual process of learning. But most of all, nobody really knows what they're doing. Doesn't matter if you've got doctor in front of your name or not. You still don't really know what you're doing. So with that in mind, here is the assumption that I'm going to make. You have just loaded up HackerOne, loaded up CRUD, loaded up Integrity, loaded up Yes We Hack, and you said, I'm going to hack an API. What do you do next? Well, that's what I'm going to show you. So first thing to note is, when is it an API and when is it an application? And how do you tell the difference between the two? Because a lot of people will either mistakenly see like a user interface and think, oh, that's not an API. I can't use any of my API security knowledge here. Or they have the other side of things, which is that they see an API and then completely miss it. Like it's there, they register, but they don't actually register, hey, this is something that I can actually. So this is what APIs look like. So often they'll be really helpful because APIs love to tell you about themselves. They are the egotistical technology. They love to say how great they are and how much they're and how widely they're used. So this is what you can expect. You can expect a URL that has the word API in, and it looks like this. It looks like plain text. An API is only different to an application because an API has no user interface. And if you're looking at Burp, it might look something like this. And same thing. One, an API will reference the word API directly. Two, it won't have any kind of visible user interface that you can interact with. It will be separate from whatever front end you see. You're going to see a lot of plain text, or in this case, JSON text. You're then going to see IDs everywhere. Now, these could be numeric IDs, they could be UUIDs, they could be some IDs encoded in a different way. They will have the word ID in there somewhere, I almost guarantee it. APIs have this really structured URL and input, and it uses a lot of normal words in the URL, users, posts. So when I'm looking at an application, I'm like, where's the API? This is what I'm looking for. These are my signals that I'm like, okay, this is powered by an API, and therefore I need to apply my API hacking knowledge. Now, just as a quick recap, this is the DNA of APIs. An API is made up of endpoints and resources. These are URLs that do something. So an endpoint is simply a URL that performs some action, performs some task. And resources are simply a thing that exists. Now, this could be a thing that exists because it's a database table. It could be a thing that exists because it's how the application works. But it's a general way of breaking up an API. Endpoints are usually HTTP GET and POST requests, just like regular applications. Now, you may also see delete and put in APIs, though to be honest, they are very rare because no API developer ever programs APIs correctly. They all kind of YOLO it and they all kind of like mess it up in their own unique ways. Endpoints will take input in the form of parameters. So these could be in the URL as URL parameters, or they could be in the body of a request as form input. APIs often require authentication and authorization. This could be an API key, or it could be something called a bearer token. For single sign-in, so login with Google, you have a very specific type of API interaction called OAuth. That is the fundamental constituent parts that make up an API and some of the technical words. Now, when you actually look at an API, it's going to use something called JSON. JSON is literally just a way of encoding data, like database results, in plain text. It uses key value pairs, which means you have a key, and then you have whatever the value of that is. So when you read this one here, let me just change my pointer to be a pen. This is the key document type, and the value is 1. This is the key no, and the value is S or whatever. This is the value of lines. Now, this is where it gets confusing. So this is an array, a list of objects, and then this says, hey, start a new object. So you would read this as the document of type 1, which has the number of S ord 101001, has a list of lines. Inside that list, there are 2 items. The first has line no of 1000. The second has a line no of 2000. So it's really important to not be afraid of JSON when you see it. It really is just a way of communicating like database results in a way that's kind of good for humans to read. Now, I know this is really overwhelming if you have never done programming before. So, depending on kind of how your brain best works, you may find that this way of visualizing helps. So, if you're a programmer, you're probably very used to this way of visualizing JSON because it's got a key and it's got a value. Now, if you are not a programmer, you may find that this way works better. This is a tool called JSON Crack, and it basically represents JSON as a tree-based structure. So here you can see you've got the document type of 1, you've got lines, and then you've got 2 objects here and here. It's a little bit easier to understand if you're, say, not a programmer, you've never used JSON before, or if you've just got JSON that's really, really big and complicated and you're not really sure how to parse that in your head. So that's the basic stuff. Where do you actually find APIs? Now, where you find APIs and what type of applications are the best to find APIs in depends on the type of API. Now, these are the 5 most common APIs you'll find, sort of. You're probably, honestly, not going to find that many SOAP APIs. And honestly, you're probably not going to find that many RPC APIs. You can, but they're a little bit rarer. So let's start with the RESTful API. Now, if you know anything about APIs, you're probably familiar with the RESTful API. They have really structured URLs with numeric IDs. They're the most common type of API. They're based on CRUD, which is create, read, update, delete. 1 endpoint per CRUD resource. It uses JSON, and resources map to the database rather than features. And I'm going to go through this one quite quickly because I'm assuming you're already familiar with it. Because RESTful APIs are kind of the default API choice for developers. They are well supported in pretty much every industry. They're rarer in applications that need instant real-time communication or that have like processing restrictions. Think your IoT devices. But they are super common in mobile apps or really any application that has a really highly interactive front end. Usually has an API on the back end. It's usually a RESTful API at that. And again, you can find these across the industry. So this is like Stripe's APIs. You can also find PayPal's API is a RESTful API. You'll find it on, I think Shopify's API is a RESTful API off the top of my head. Actually, no, I think they're GraphQL. But anyway, they are very, very common. There is not one application type that you're going to see these more in. They can pretty much be found everywhere. And so if you've started up HackerOne, you started up BugCrowd, you're looking for a program, if you're looking for an API and you're going to just go for the default option, you'll usually find a RESTful API. Then we have GraphQL. GraphQL is a little bit different. So GraphQL only uses a single endpoint, usually /GraphQL. A user essentially builds the perfect query to get whatever input and output they need, rather than the API developers telling you what this API returns. So it supports queries. They are the things that fetch data, and mutations, they're the things that change data. The data is highly connected. It associates different database tables together. So here you can see we've made a query for this user, which has this user ID here. We've then asked for its ID, its name, is viewer friend, their profile picture, but also their friend connection here. And we've said, hey, get us the first 5 friends. We can see we've got a total count, and then we've got this other nested object here, friends ID name. And what that's essentially doing is saying, hey, don't just query this user, query the users that are friends with this user. So you have these much richer connections between pieces of data, which you should hear as API hackers as, wow, I can get a lot of data out of these queries if I know how to ask for it. Now, thankfully, you don't actually need to know how to ask for it, because it supports something called introspection. So introspection means that with GraphQL, you can query both the data, but also the metadata, asking the database and the API directly, hey, what parameters do you accept? Hey, what are all the queries? Hey, what kind of data can I request from this query, etc. And the benefit is it only really needs HTTP post requests. They're actually very, very easy to spot. So where do you find GraphQL APIs? Now, GraphQL is definitely rarer. It's still gaining popularity, and certainly there's been a lot of discussions in like the API developer space about whether or not GraphQL is good still. Um, it is still quite rare to see it. It's generally used by teams with kind of the cutting edge of software, who don't need to support legacy systems, or in areas where flexibility is really important, like startups use them quite a lot because you don't have to define how an application is going to work for the application to work. Instead, you can kind of flexibly say, okay, I might need this data in the future. I might not need this data in the future. Again, it's very common in kind of newer startups, tech focused organizations or industries, or for applications that need to be really highly connected. It is less common in any industry where like how quickly you can handle data is impacted, because it takes up a lot of processing power. The results are not going to be within milliseconds. It's going to take a bit. Now, saying all of that, if you're like, well, I want to hack GraphQL APIs, where should I go? Look for startups, look for newer technology, look for the the new kids on the block. They're often going to be using GraphQL, and you can see this because places like HackerOne use GraphQL really heavily in their APIs. Then we've got RPC APIs, and we're starting to get into the more niche skills now. So RPC APIs, you might have heard of JSON RPC or gRPC before. RPC broadly stands for remote procedure calls, which is essentially an API that focuses on functions rather than fetching. So think turn light on, not what is the exact like color temperature of the light. So JSON RPC uses JSON, as you might expect. This is an example on the screen. While gRPC uses something called protobufs, which look like raw code. And you're essentially just sending raw code to the API. Now, what you'll see is it will have a method, usually a function name, and then parameters, e.g. array. And it looks a lot like writing code because it kind of fundamentally is. If it does return any data to you, honestly, it's not going to be much. Sometimes it will just be like a success message because it's designed for use where processing time is important, where you don't want the overhead of RESTful APIs or the overhead of GraphQL APIs because that would slow it down. So you see these a lot in things like IoT devices, for example. So where do you find them? So RPC is primarily used in applications that really aren't fetching data, that is just doing some kind of function. Instead, they call specific functions and may sometimes use the output of those functions. So again, you can see the example here. This calls this function here, this add numbers, and you can see that like literally the result is just the addition, like the arguments added together. It is very, very lightweight. So it's time sensitive processes. It's really, really good for. Very common for basic IoT devices. Turn this on, set this temperature. What is the status of the fan? Really, really, really common. And also a lot in Web 3.0. So your crypto, your stuff on the blockchain, your NFTs, they'll also use JSON RPC because often when you're handling stuff on the blockchain, you don't want the high level of overheads because that means more what's called gas fees, which means have to spend more to make any transaction. And so these are really APIs that you find in IoT and Web 3.0. So, and my recommendation for you, if you're considering hacking these kinds of APIs, and they're really good places to hack because not many people look at them. One is go and check out Web 3.0. Now, Web 3.0 bug bounty is a bit, it depends on the website how good it is. I know there's a lot of controversy there. But for the most part, I think being able to look at these kinds of things for IoT devices is really, really good, especially if you're not confident enough to jump into something like a bug bounty program. You probably have some smart devices just laying around. This is a smart plug by IKEA. You probably have some of these lying around. Why not just go and take a look and experiment and see whether or not you can, find a vulnerability? Then we've got SOAP. SOAP is the bane of a lot of developers' existences. It uses an envelope structure with this header and body. It's very similar to HTML, and you might recognize it as HTML, but it actually uses XML rather than JSON. It has way more complex objects. It uses tags instead of key value pairs. You can create tons of different complex relationships between both like keys and values. You can add parameters in there. In fact, XML has kind of had a bit of a renaissance recently with AI because because XML has this like richer context. It actually can be better to kind of direct an AI using something like XML rather than using JSON because again it has a bit more complexity in there. The header contains parameters rather than your URL. So you can see here, this has a date and time. You can see this has a reservation. You can see this has a ID up here. It's really an older method of implementing APIs, and it's widely used in legacy applications, but it has a lot more overhead as just the data that is being transferred is larger. Like, this is really complex data. There's lots and lots of stuff in there. It's kind of ugly. Like, there is a ton of overhead here. Now, where you find SOAP APIs, and hopefully this inspires you to have a go at hacking them, SOAP was really the most common API architecture before REST came along. It is widely used in legacy applications. And what you should be hearing when I say it's widely used in legacy applications is that has a lot of vulnerabilities in it. So while a lot of applications have now moved to things like RESTful APIs, um, actually, because it's widely used in legacy applications, it's really common to for an organization to have looked at their SOAP API, gone, this is really insecure. I'm going to fix X, Y, and Z problems in the security. And then they've kind of gone back and actually like fix those vulnerabilities. For a lot of applications that are still in SOAP, they are like, do not touch, like laptop is running a server kind of level, right? It is one of those things where you don't want to touch it in fear it breaks. So again, a lot of these are really insecure. A lot of them weren't developed at a time where security was prioritized like it is now. It's also really common in like more Windows focused development, ASP and .NET. You'll see a lot of XML in general. But fundamentally, these are going to be older legacy applications or internal APIs. Now, from a hacking perspective, they can be really, really good because when you're like looking at these applications, they're older. Saying that, a lot of them have now been put behind firewalls, so you might not have the same level of access. However, if you work at an organization that has legacy systems, this could be a really great way for you to potentially pivot from something like an IT support role into a security role. You could offer to take a look at some of these older legacy applications and practice both your hacking skills and show that, hey, I really want to move into security as part of my career. Now, finally, we have MCP. And if SOAP is the decrepit old man in the corner slowly wasting away, MCP is the Gen Z Zoomer going around because MCP stands for Model Context Protocol. It is an API that is used for AIs to interact with applications or functions outside of the AI itself. Now, what we see this a lot in is something called agentic AI. So, this is where instead of AI being a single chatbot where you just tell it, write me some code in one chat window and you tell it, give me some suggestions for dinner in the second chat window, these are agents that can run kind of independently from your requests. So you'll give it a broad request like, hey, make this application for me. And it will go, oh, to do that, I'm going to need an agent that can edit the file system. I'm going to need an agent that can write Python code. And they're all going to work together. Now, when AI people talk about MCP, they say it's not an API. It's the new version of an API. It's still an API. So the idea is that if you have an application or a function, you would run a MCP server that allows AI agents to interact with the thing you've made. So maybe you've made a to-do list calendar. You're going to have an agent, you're going to have an MCP server that would allow an agent to say, add to the calendar, add to the to-do list, or mark a to-do as done. It can also call other APIs because, as I mentioned in the last API SecCon, all AI is just APIs. Though it tends to use standard I/O for lightweight communication and typically uses like similar JSON RPC, though technically it's not an RPC server, it's just using the structure of it. Again, a lot of AI people talk about it as more like an adapter for AI than it is an API for AI. Though I think it helps to think about it more like an AI native API. So instead of calling RESTful APIs via the AI, or the LLM, the agent will call the MCP server that will then make the API request. It adds another layer of like complexity to the system. However, it does enable kind of a bit more interesting use cases. Now, again, it's not strictly an API. It's supposed to have a lot of flexibility in it. It's really only used for AI applications. And if you're thinking, man, I want to get into API security, but I'm worried that I'm already too late, actually looking at AI can be really, really helpful because AI applications, they have no idea what they're doing. Like, I say this as somebody who introduced myself as saying, you don't need to know anything to do API security. They know even less than you guys do. So like it's good. It's ripe for the taking. Okay. You can find vulnerabilities there. So any kind of application that's implementing kind of AI native features now is such a good place to look for vulnerabilities. So what you're looking for here is applications that have something like a like a API integration they've just created. They're experimenting with AI. They use the term MCP. And really what you're testing for is things like access control issues. So we talked a bit about the different kind of API architectures. Now, I wanted to just give you a rundown of the different types of APIs and where you find them. So, first off is developer APIs. Now, if you've seen an API, it might have been this kind. These are APIs that are public, that are designed for the public to consume them. And the idea is it allows an application to kind of build very quickly by allowing third parties to easily integrate existing software into a new product. If you've heard of the Twitter API, that's this. Now, these APIs are often considered products and therefore have a cost associated with them, but you're going to find them on things like social media platforms, payment processors, development tools, inventory management, etc. Your Recon approach, if you're looking at a developer API, is to read it. No, really, just read it. It's genuinely the easiest way to understand it. So, do I recommend these for beginners? I actually don't recommend developer APIs for beginners. While they do have the most amount of information available, while they do have the most, like you've got the docs right in front of you, they are often like really, really oversubscribed when it comes to actually looking for vulnerabilities. So, I give developer APIs a skip. Public APIs. Now, public APIs are publicly accessible, but they are not designed for the public. So what do I mean by this? Well, the idea is that for things like mobile applications or highly interactive JavaScripts to work, the organizations must publish an API publicly, but it is not designed for members of the public to actually use and interact with. It is only designed for internal developers. So you often won't have an API specification. You're not got a Postman collection. You've not got a Swagger file. You've got a single piece of JSON, and that's it. And these are, again, the most common types of APIs and actually the easiest to hack when you don't really know what you're doing. You're going to find them in any and all industries. And the best way to do it is to brute force API endpoints. And I'll talk a bit about that in a moment. The next API type I recommend you take a look at are data consumption and data connectors. So these are an API type we're seeing more and more common and more pop up. So these are designed for software companies to essentially take data from one thing and put it into another thing. Now, often the way we see that is through AI. So a lot of the time they'll get information from, say, your email. They'll turn that into a little connector that will then connect up to an AI thing that they've sold you too much money for. And essentially, the API is in that little connector. These are very complicated. However, I really recommend looking at them because they are often documented, even the same level as like developer APIs, but they don't have the same amount of scrutiny as the developer API would because they're often very new. These are new types of APIs that are coming up now because of things like AI, because of things like platforms that are just for data analytics. They can expose really large amounts of sensitive data about their customers. And the Recon approach here is really find public facing documentation. If you've never seen documentation before, this is kind of what it looks like. You have your list of resources on the side here. You have a list of endpoints that you can access. You've got the list of parameters that you need to give it. You've got any required authentication that you need. You've got information about what the response is. And then you even have some example code. So if you're looking at these kind of data collectors, often you'll have this level of information, this level of detail. It's just going to be in the form of kind of like developer docs, right? So if you haven't got public documentation, what if you're looking at something and you have no idea what to look for? Well, fear not. This is what a RESTful API looks like. RESTful APIs are really structured applications. They are they have a API endpoint, they have a purpose, and all you need to do is the API has dogs, you're going to replace it with another likely resource name. You're going to change dog to cat. to rabbit to guinea pig. You're going to change, dogs down here to cats. And then the next thing you need to do is go from one of these endpoints to one of the other CRUD endpoints here. And then you can test again for other types of vulnerability. But I leave you with this. The best way to understand an API, the best way to start API hacking is just to use it. And so what I want you guys to do as I'm finishing up my talk here is stop listening to me, look at a bug bounty, look at an open source API project and experiment with it. Just try it out. Just try hacking it. You already know way more now than when I did when I found my first vulnerabilities. Thank you very much.
So thanks for that. Mo asked, how would you detect the presence of SOAP APIs? My response to him was by analyzing request traffic because it looks so unique, but I'm curious what your thoughts are.
I mean, anything where you see a lot of XML is really, really rare to find in applications. Like you very rarely see XML. And so whenever you see XML, you should be thinking, hey, is that a SOAP API? Though looking for the word header and envelope help a lot, especially envelope, because you don't see it in any other context.
What factors of GraphQL make it incompatible with legacy systems?
So primarily, nothing makes it outright incompatible with legacy systems. It is a very different way of thinking about it, though. There is part of hacking that is about understanding how developers build software. Now, GraphQL is a different approach to how developers build software, not in the fundamental software like composition. So what GraphQL says is I don't know what resources I want to expose in my API. I don't know what endpoints I need for my API. And that is the difficult part is more on the developer side. So honestly,
Right.
it's actually not that difficult to like plug it in replacement of like a RESTful API. But it does take a
Right.
lot of confidence for developers to do that. Also, because I know it's going to come up, I did actually prep another slide because somebody's going to ask, how do I do GraphQL without introspection turned on? So here is a little demonstration that I created. So this is me exploring HackerOne. And HackerOne uses a GraphQL API, and you can see
Mhm.
I'm just pressing buttons here. Introspection isn't enabled. You can't just see the introspection query. However, you can recognize GraphQL queries and actually create your own list of queries here.
Mhm.
So the regex, this is logger plus plus. This is the regex that you want to use, this top one here. So just because I'm going to head that off now, because somebody is going to ask, but how do I do it if introspection isn't turned on? You can use this regex to do the recon. I'll leave it up so people can steal it. Please do feel free to steal, guys. It was really helpful when testing GraphQL just to see what you have access to.
Yeah, absolutely. Not having introspection is definitely a challenge. Well, I think that's all I have for you, Katie. Thank you so much for being here.
Like and subscribe to my YouTube channel.
Please.
InsiderPhD.
Okay, thank you. I thought.
Thank you so much for having me, everybody. And it's been a pleasure to be here and to close out APIsec.